Hi there, you're welcome back to this channel. In this video, I'm going to take you through partial derivatives. I have problems here for us to solve so you understand this concept well. If this is the first time you've been on this channel, this calculus family, please subscribe to support and kindly watch this video to end to so that you understand every part of the video. So let's take the first problem you have on board. So solution. So my the first problem here is f of xy is equal to x to the power 4 plus 6 root y minus 10. This is a multivariable function. We want to find derivatives of multivariable functions. When we say multivariable functions from our previous lessons, these are just functions that takes in more than one input. Okay, so f of xy, f of xyz, and so on and so forth. So you have to find derivatives of multivariable functions. To do that, you need to find it separately. So with this function, I need to find derivative with respect to x separately and with respect to y separately. Now, at this point, let's do what you're supposed to do. So for the partial derivative with respect to x, you simply write fx, and fx is equal to d of the expression f of xy, everything over the x. So you are trying to differentiate this entire expression with respect to x. The key thing is when you are differentiating with respect to x, any non-x variable turns zero. Oh, sorry, becomes a constant. Yes, becomes a constant. So if I am, let's say, differentiating with respect to x, then this y here is a constant. It's a constant. Okay, so what am I getting? The first term here is x, so I can go ahead to differentiate this and I'll get 4s cubed by fundamental derivative principles. For the second one, 6 root y is purely y. It's a constant, so when I differentiate, I'm getting 0. Negative 10 is also a constant. I'm getting 0. And I'm getting 4s cubed as the partial derivative with respect to x. Let's find the fy with respect to y. With respect to y, I'm getting the expression x to the power 4 0. 6 root y. What is 6 root y? 6 root y, you are going to get, whenever you have 6 root y, this is the same as 6 multiplying y to the power half. So to differentiate this, you multiply half by the whole expression, and that gives half multiplying 6y. Then you subtract 1 from the power, so you get 1 out of 2 minus 1. This is giving 3y to the power negative half, right? So my fy is simply 3y to the power negative half. I can make this. Please, normally whenever you are doing derivatives, try to express your answer as the form the question gave. The question gave it in radical, so try and leave it in a radical form. Please take note. So here you are going to get 3 over y to the power half, because here is negative. Okay, so this is the same as 3 over root y, and we're good to go. When you differentiate, negative 10 is 0. When you differentiate, x to the power 4 is 0, because we are differentiating with respect to y. Let's take the second question. I have w is equal to x squared y minus 10 y squared c cubed plus 43x minus 7 tan 4y. So I want to find derivative of this function w with respect to each of the variables here. I have x, I have y, and I have z. X, y, and z. So I'll start with wx. So as we did here, I'll tackle the first expression. Do I have x? Yes. What is x? It's x squared. When I differentiate x squared, I'm getting what? 2x, and I'll add my y to it like this. Minus this expression, there's no x here, so apparently you get what? 0. So minus 10 y squared z cubed. So I mean this expression here, there's no x, so it returns 0. Now we move to the next one, that is 43x, right? So for 43x, when I differentiate, since there is x, I'll get plus 43. Okay, I get plus 43. Now I have negative 7 tan 4y. That is, there is no x here, so it's also 0. So with respect to x, I got 2xy plus 43. Let's find wy. For wy, when I start x squared y, my x squared is now a constant, but y is not a constant because I'm differentiating with respect to y. So when I differentiate with respect to y, I'm getting 1. So I'll get x squared times 1. Now minus, I have y again here. So what am I getting? 2y. 2y will multiply the rest of the expression. So minus here. So 2y will multiply the rest of the expression. So I'll have minus 2 multiplying 10 y z cubed. Then finally, not finally, okay, here I have 43x. There is no y, so it's 0 plus 0. Then here I have negative tan 4y. So there's 4y here. So I have to try and also differentiate this. Okay, so plus here is a composite function. You have 7 tan 4y. This is calculus 3, so it's expected that you've done calculus 2 and you know how to differentiate trig functions, right? So the point of interest is not coming to prove how you get the derivative of this expression. Now if you differentiate a tan x, you should get set squared x. Is that not it? Yeah, set squared x. So for that reason, here I'm going to get 7 tan, sorry, 7 sec squared of the argument here 4y. But since 4y is not x, I'll have to differentiate it. You know that the x here is the same as 4y, so x is equal to 4y. So therefore, I'll have the x to the y is what? 4. So you have to multiply this by 4 using the chain rule. So my wy simply becomes x squared minus 20y z cubed plus 28 sec squared 4y. And that gives us with respect to y. So let's go to with respect to z. With respect to z, that is wz. With respect to z, so with respect to z, I'm going to get wz. The first expression, there's no z in it, so it's 0. The second expression, there is z here. And when I differentiate z, I'll get 3z squared, right? So minus 10y squared, 3z squared. For this is 43x. I don't have any z in it, so it's 0. Then for this last part, negative 7 tan 4y, I don't have x, so it's also 0. So my wz is also equal to negative 10y squared times 3z squared, which is the same as negative 30y squared z squared, like that. So at this point, you move to the c. H of st is equal to t to the power 7 natural log of x squared plus 9 on t cubed minus 7 root x to the power 4. So let's solve this. So it's h of st, right? So h of st, if I want to find the partial derivative, I'll have to find hs. That is with respect to x alone, with respect to x alone. So once I'm finding hs, then it's going to be the first expression. I have t to the power 7 natural log of x squared plus 9 over t cubed minus 7 square root of x to the power 4. So with respect to x, I have x here. So meaning I have to differentiate this expression. T to the power 7 is now a constant. How do we differentiate a natural log question, or a natural log expression, sorry. So if you have ln of x, the derivative is equal to 1 over x. How did we get 1 over x? It's simply the derivative of whatever you have here over itself. So it's x prime over x, right? So here too, I'll differentiate what is in this argument over itself. So I'll have t to the power 7 times, when I differentiate this, I'll get 2s over s squared itself. Do I have s here? I don't have, so it's 0. Then I move to the last part. This is the same as negative 7. This, sorry, it's not negative 7, it's the 7th root, okay? So here is a small 7, a small 7. So whenever you have this, it's like a 7th root. So I have s to the power 4 to the power 1 out of 7. This is the same as s to the power 4 over 7, right? So with this, if you want to differentiate, you just multiply 4 on 7 by the expression, then you subtract 1 here. So when I subtract 1 from 4 on 7, what am I getting? Negative 3 on what? 7. Negative 3 on 7. So my derivatives here becomes negative 4 on 7 multiplying h to the power negative 3 on 7, right? So let me further simplify this. This gives, this x here will cancel this x by 1, and I'm going to get, going here 1, cancel here 1. So I'll have t to the power 7 times 2 all over s minus, here becomes 4 over 7 x to the power 3 over 7, because here is negative, so I brought it down. So I'm getting this, further simplify, I'm getting 2t to the power 7 over s minus 4 over 7 multiplying the 7th root of s cubed as that. So always take note, you have to bring it back to as it was, and that is hs. So ht is simply equal to, when I come here, there is t. So when I differentiate t, I'm getting 7t to the power 6. This is a constant, it remains the same. Plus there is another t here. So this is the same as 9 to the power t to the power negative 3, right? So let me clean some parts. So when I have 9 over t cubed, this is the same as 9t, sorry, this is the same as 9t to the power negative 3. So with this one, I'm going to have negative 3 by 9 t to the power negative 3 minus 1. So I'll have the expression to be minus 3 by 9 t to the power negative 3 minus 1. There is no t here, so here 2 is 0. So I'm going to get 7 t to the power 6 natural log of x squared minus 27 t to the power negative 4. And that gives me my partial derivative with respect to s and t. Then finally, the last equation comes. So the d f of xy is equal to cosine of the expression 4 on x e to the power x squared y minus 5 y cubed. So to find fx and fy. So let me find fx first. So to find fx, you look out for this expression here, cosine of 4 on x e to the power negative e to the power x squared y minus 5y cubed. So now you see that this is a trig function multiplying what? An exponential function, and we are going to use a product rule in this case. So to use a product rule, I'll take what I have here first and I'll differentiate it whilst maintaining this expression. Then after, I'll maintain this expression whilst differentiating this side as well. So to do that, I'll simply write. Now with respect to x, you ask yourself, where do I see x in it? So I can see x somewhere here. Alright, I can see x somewhere here. So meaning the two different functions possess x. So differentiating this expression here with respect to x, what am I getting? Now, this is a cosine function. I want to differentiate it with respect to x. When I differentiate cosine x, I'm to get sine x. So when I differentiate cosine x, I'm to get sine x. Cos x is equal to what? Sine x, right? Negative sine x. But now it's not cos x alone, it's 4 over x. So once it's 4 over x, you have to find the argument. So meaning that this x here is equal to 4 over x. So you have to also do the simplification in here. It becomes a chain rule, okay? So therefore, you differentiate the entire function and also differentiate what I have inside. Differentiating the entire function, I'm getting negative sine of what? 4 over x. And if you want to differentiate what is inside here alone, because composite, I'm going to get, this is the same as 4x to the power negative 1. So you get minus 4x to the power negative 2, because you get 4x, the negative 1 multiply the entire expression, then you subtract 1. So multiplying negative 4x to the power negative 2. This is when I have differentiated the cosine part alone, whilst maintaining e to the power x squared y minus 5y cubed plus, now I have to maintain the cosine part too, then differentiate this part. So that one will be cos 4 over x. Now I want to differentiate this side. To differentiate this side, what am I getting? I'm getting, this is exponential function, right? So all that you have to do is differentiate the exponent and multiply by the same expression. When I differentiate the exponent, I'm getting 2xy, but there is no x here, so it will be 0. Okay, so because I'm differentiating with respect to x, 2xy multiplying e to the power x squared y minus 5y cubed, like this. So the final expression is equal to negative here, they will multiply to be positive. So I get positive 4 over x squared multiplying sine 4 over x e to the power x squared y minus 5y cubed plus, when I come to this side to bring 2xy cosine 4 on x multiplying e to the power x squared y minus 5y cubed. So that happens to be only with respect to x. Now let's go to with respect to y. So with respect to y, I'm getting fy. So that one is very simple. Because there is no y here, the cos 4 over x simply becomes a constant. So I focus straight on the exponential part. So this is not by part, okay? This is not a chain rule. So I'll have to just get my cos 4 over x here. Is that not it? Then the e to the power will follow. So to differentiate e to the power x squared y minus 5y cubed with respect to y, I simply differentiate the power, then multiply by the whole expression. So I get x squared y, but y here is 1. So you differentiate, you get 1. So x squared minus, here is 5y cubed. So minus 15y squared multiplying e to the power what? Multiplying e to the power x squared y minus 5y cubed. So this gives us our fy. Thank you for being with me in this video. Please don't forget to subscribe, like, and also share.